Okay, we're going to solve this first order linear differential equation and also determine how the long-range behavior of the function of the solution depends on y naught. And of course, there's a typo. That should have been a t as t goes to infinity. Okay, so let's change this to linear form. Dy dt minus 3y is equal to e to the 2t. So let's get the integrating factor. We have mu of t is equal to e to the integral of negative 3 dt. And clearly that's going to be e to the minus 3t. The integral of negative 3 is negative 3t. Okay, so using this, we can establish that the solution of this initial value problem is going to be integral of the right-hand side, e to the 2t, times this integrating factor, e to the minus 3t dt, all divided by the integrating factor, e to the minus 3t. So we get integral of e to the minus t dt divided by e to the minus 3t. Integral of e to the minus t is going to be negative e to the minus t plus c over e to the minus 3t. And so simplifying this, we get y of t is equal to, this first part is going to be or the second part here is c times e to the 3t. And then this first part is going to be minus e to the 2t. And so that is the general solution of this initial value problem. We are also given an initial condition, so let's use that. So y of 0 is supposed to be equal to y naught. If I plug in 0 into this, I get c times 1 minus 1. And so that means that c is equal to y naught plus 1. And so our initial value, if I use the initial value, that's going to be equal to y naught plus 1 times e to the 3t minus e to the 2t. Okay, so that's the solution. Then there is a question about how the solution behaves. Determine the long-range behavior of the function if t as t goes to infinity depends on y naught. Okay, first thing to establish is that e to the 3t is going to dominate e to the 2t. E to the 3t grows faster than e to the 2t. And so this term is going to be the most important for determining how the function behaves. So in particular, if y naught is greater than negative 1, then the number here is positive. It doesn't matter what this is. And so the limit as t goes to infinity of y of t is going to be positive infinity, because I have a positive number times e to the 3t, and this part just simply doesn't matter. On the other hand, if y naught is less than negative 1, then what I see here is going to be a negative number. So a negative number times something blowing up to positive infinity is going to blow up to negative infinity. So limit as t goes to infinity, y of t is equal to negative infinity. Now finally, there's one case left, equals. If y naught equals 0, then this part goes away completely. And then y of t is equal to just negative e to the 2t. Now, so when that happens, as t goes to infinity, that also blows up negative. So equals, if it's less than or equal to negative 1, it blows up to negative infinity. And if y naught is greater than negative 1, it blows up to positive infinity.